Uniform distribution. Suppose the smiling times of 8-week-old babies are uniformly distributed between 0 and 23 seconds, inclusive. Let x be the length in seconds of an 8-week-old baby's smile. We were given a uniform distribution, which is a continuous distribution. For any continuous distribution, the first step in solving the problem is to draw the graph. In this case, this is a uniform distribution, so we draw a horizontal axis and label it at x, and on the vertical axis we'll set p for the probability. For the uniform distribution, the graph is a horizontal line. It is a line that is parallel to the horizontal axis, and it is defined between 0 and 23 only. The total probability under the curve, and in this case, the curve is only defined between 0 and 23. The area under the curve between 0 and 23 is the area of the rectangle. And so we have the width. The width is 23 minus 0, which is 0. We don't have the height. We need to find the formula for this horizontal line. But in a rectangle, we know that if we take the width times the height, then we get the area. And again, the area needs to be 1. The width is 23, the height is unknown. 23 times h is 1, so h has to be 1 over 23. And so the probability is 1 over 23 uniformly for any value between 0 to 23. And this is the graph of a uniform distribution given the parameters 0 and 23. Part A. Compute the mean and the standard deviation of the smiling time. The mean of a uniform distribution with the parameter A and B is A plus B over 2, or the midpoint or the average between the two. 0 plus 23 over 2 is 23 over 2, or 11.5. And in this case, the unit would have to be seconds, because the unit for 0 is seconds and the unit for 23 is seconds. What this means is that the average smiling time of an 8-week-old baby is 11.5 seconds. Next, we need to compute the standard deviation, but before we compute the standard deviation, we need the variance. And so the variance is defined to be a minus b, or b minus a squared, divided by 12. A is 0, b is 23, the whole quantity squared. Since we take the whole quantity squared, it doesn't matter whether we take a minus b or b minus a, divided by 12. And this will give us 44.08333. To get the standard deviation, we simply take the square root of the variance. So the standard deviation is the square root of 44.08333, which is 6.64 if we round it to 2 decimal places. Notice that we kept 4 decimal places when we found the variance, and then when we compute the standard deviation, we round it to 2 decimal places. What is the probability that a randomly chosen 8-week-old baby smiles between 2 and 18 seconds? To answer this question, we would need to draw the graph and shade the area between 2 and 18 seconds. We simply copy this graph down from earlier. We have a probability density function with the height of 1 over 23 earlier, between 0 and 23. This graph is only defined between 0 and 23. However, for this probability, we need to shade the area between 2 and 18. And so we would draw the vertical line from x equal 2 all the way up to the graph. The same thing, we would draw the vertical line at x equals 18. And since it's say between 2 and 18, we would shade the area under the curve above the horizontal axis between 2 and 18. For the continuous distribution, the probability is the area under the density curve. And so in this case, in symbolic form, we're looking for the probability for the smiling time between 2 and 18. So 2 is less than or equal to x less than or equal to 18. And again, this is just simply the area of the rectangle. This rectangle has a width of 18 minus 2 and the height of 1 over 23. And if we take 18 minus 2, we get 16. 16 over 23, it is approximately 0.6957. If we round it to 2 decimal places, then it would be 0.70. And lastly, find the probability that a randomly 8-week-old baby smiles more than 12 seconds, knowing that the baby smiles more than 8 seconds. The part that is knowing is the condition, the given part. So this is the conditional probability. In symbolic form, we're looking for the probability that the smiling time is more than 12 seconds. However, that notice with the condition that the baby smile more than 8 seconds. Observe that this is a continuous distribution. It doesn't matter whether we use the greater than or equal sign in this case. Using the conditional probability formula, we have divided by the probability of x greater than 8, and in the numerator, the probability of x greater than 12 and x greater than 8. Now, if we look at the graph, the intersection that is greater than 12 and greater than 8, it has to be only 1. And so this is 12, and let's just say this is 8. If the area is greater than 12, we will shade it more than 12, but again, it has to be less than 23 because the graph is only defined from 0 to 23. And greater than 8, we shade everything on the right hand side of 8, but still we need to stop at 23. And so the part that they have in common, the intersection, is 12 to 23. And the probability of this is the area, and the area of the rectangle is 23 minus 12 times the height. The height is still 1 over 23 over. Now in the denominator, the probability of x greater than 8, and the probability of x greater than 8 is the area of the green rectangle, which is 23 minus 8 times the height 1 over 23. 1 over 23 cancelled out. 23 minus 12 is 11, and 23 minus 8 is 15, and 11 over 15 is 0.7333. We round the probability to 4 decimal places here.